So we're going to talk about R combinations, which we've talked about previously, but now with repetition allowed. So here's our question that we want to look at and examine. So how many ways are there to choose R elements without regard to order from a set of n elements if repetition is allowed? So we looked at this question before, but we didn't have repetition. So now we're going to allow repetition when we want to know how many ways are there to do this. So let's start with our definition. We're going to say an R combination with repetition allowed this is also called a multiset of size R. So you start with the set, so chosen from a set called the set capital X, and it has n elements in it, is an unordered, order doesn't matter here, unordered selection of elements taken from X with repetition allowed. So the way we're going to denote multisets is instead of using the curly braces, we're going to use square braces. So let's look at an example here. So write a complete list to find the number of 3 combinations with repetition allowed. Or another way to say this is multisets of size 3 that can be selected from the set 1, 2, 3, 4. So remember that with these 3 combinations with repetition allowed, order doesn't matter here. So I'm just going to write things in increasing order. And we're going to go systematically. So we use these brackets when we're doing multi-sets or combinations with repetition. So what are all the possibilities if I select 2 ones? So remember, there's repetition, so I select 1 and then I select it a second time. Well, the third element could be 1. You could select two 1s and a 2, 2 1s and a 3, or 2 1s and a 4. And those are all of the multi-sets where you have 2 ones selected. So now, let's say I pick a 1 and a 2. And here, because we're writing things in increasing order, I don't have to think about 1. So my third element could be a 2. It could be a 3, or it could be a 4. So those are all of the ones that have a 1, 2 in them that haven't been listed earlier. Then write down all the 1, 3s. So 1, 3. And again, you're writing in increasing order. So the 3 could be the next number, or 1, 3, 4. And finally here, or in this batch, I guess, we could select 1 and 4. And again, we're writing in increasing order, so the next largest number would be 4. All right, now those are all the ones that contain a 1 in them. So now let's look at the ones that contain 2s in them. So 2 2s, and then the option is a 2, a 3, or a 4. Those are all the multi-sets with 2 2s in them. Well, then we have, you could select a 2 and a 3, and then the options are a 3 for the third one, or a 4. And then finally, in this group, I could select a 2 and a 4, and then another 4. And then those are all of the multi-sets that contain 2s in them. So now move on to 3s. If I have 2 3s, then I could have another 3, or I could have 2 3s and a 4. I could have a 3, 4, and a 4, or all 4. So those are all of the multi-sets. So again, order doesn't matter here, where I'm allowed to repeat numbers from the original set. So if you count up how many of these there are, there's, let's see, there's 4, 3, 3, 3, 3, 3, and a 1. There's 20 in total. So there are 20 3 combinations with repetition allowed.